Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fawzan bin Muhammad Saleh. I'm from CS256A. My ID is my supervisor is Miss Nurul Najwa binti Abdul Rahid, and the project that I'm going to present is my FYP is Dashcam with cloud storage using Raspberry Pi with Ffmpeg video compression. Okay. The project background. Dashboard camera, or sometimes known as dashcam, are becoming popular in vehicle equipment for recording audio and video footage, and video recording and the audio and the video recording for the dashcam has become significant piece of evidence. The video recorded by the dashcam can be used as an evidence in event of a road accident, and when the car is parked, the dashcam can capture video as an evidence if vandalism is detected by 360 parking monitor and send it to the owner. And also, for this project, I use Raspberry Pi as the dashcam. Raspberry Pi is a low-cost credit card-sized single-board computer developed in the United Kingdom by the Raspberry Pi Foundation in association with Broadcom, a mobile chip architecture capable of becoming a media centers, file server, vintage gaming consoles, router, and network-level ad blockers by amateur computer enthusiasts. But most importantly, the Raspberry Pi has the ability to interact with the outside world and has been used in a wide array of digital makers projects, from music machines and parent detectors to weather stations and tweeting birdhouse with infrared cameras. And also, in this project, I will use cloud storage as to store the data, which the cloud storage is a storage space that may be used to store data on remote servers and can be accessed anytime from any location and easily shared with those who are granted permission. And also, for the compression, I'm going to use Ffmpeg is a leading multimedia framework able to decode, encode, transcode, MUX, DMUX, stream, filter, and play pretty much anything that humans and machines have created. It supports the most obscure ancient formats up to the cutting edge. Ffmpeg is a powerful software that can perform virtually anything with multimedia files. Okay, so in my project, the problem statement, there are three problem statements. Okay, as we know, dashcam, a lot of people use dashcam, right? And the dashcam, but sometimes, okay, normally dashcam, they use an SD card, right? So when they use an SD card, sometimes, okay, the cheap kind of dashcam, there's a storage limitation, okay, in there. Sometimes if the chip, maybe we buy a cheap one, the memory size, maximum memory size is it can handles is a 32 gigabyte of SD card. And if we purchase an expensive one, maybe the expansion, the SD card that it can support is 128 gig. Okay, so there's still a limit on the storage, right? So in order, so because of that, and also storage mesh limitation, we can also see that the size of the video from time to time has become more bigger because the resolution of the files is becoming more bigger, and the file size, the storage required is becoming more higher. So because of the 128 gigs, we have a storage limitation in there. And also, the second one is the corrupted files. So maybe we know that sometimes the SD card, there's still a dead, not deadline, means that SD card sometimes they don't live really long. So the SD card can sometimes broke, and maybe the files inside it might be corrupted. So that's the problem. So because of that, we can't retrieve any of the video when the time that we need it. And also the last one is the difficult to access. Okay, difficult to access means that, okay, each time we want to retrieve the video, we need to go to the dashcam, retrieve the SD card, and then put it on our camera, our laptop, and then retrieve the files. So actually that's quite a hassle, because each time we want to do that, we want to retrieve, we need to get the dashcam, we need to put it inside the laptop, and then just like that. So it's quite a hassle. So the objective of this project is to design a dashcam with cloud storage using Raspberry Pi with Ffmpeg video compression. Secondly, to develop a dashcam with cloud storage using Raspberry Pi with Ffmpeg video compression. And lastly, to test the efficiency of the Ffmpeg compression in reducing the size of the video. So we can see that with the help of the dashcam with the cloud storage, we can store the files instead of inside the SD card. We can store inside the cloud storage. So and also the FFF video compression, it will compress the file and then upload it. So the size of the file will be much more smaller to save data, and also much more faster because the file size is not too big. So it will reduce the time taken to upload to the cloud. Okay. So the project scope of my project is to develop a dashcam prototype using Raspberry Pi with 1080p camera module, and also compress the recorded video using FFmpeg video compression before uploading it up to the cloud storage. So the project significance: the user will not have to worry about storage limitation. Okay. And also, video captured by the dashcam will always be backup to the cloud, which will prevent from any file corruption or loss. And thirdly, the user can easily access the recorded video on the cloud using smartphone from anywhere and anytime. Okay, this is flowchart of my project. So the user just came to the dashcam. Okay, open up the app connect to the dashcam through Bluetooth, and then user press start recording. Okay, so the dashcam will start recording, and then if no, start recording, and then until the user presses stop, it will keep on recording. So if the user press stop, yes, it will save the recorded video to recorded folder, and also the FFmpeg will compress the video from the recorded folder to the compressed folder, and also it will upload the video from the compressed folder to the cloud, and then the end. Alright, so this is my logical diagram for the project, which is this is the dashcam, this is the camera module. Okay, the user can control the dashcam through Bluetooth using the mobile app. Okay, and then the dashcam will upload the video files to the Google Drive, and then the user can easily access the Google Drive through the internet. Okay, so result and analysis. Okay, so from here we can see there's a lot of from the what I found. The Ffmpeg video compression really did a great job where it compressed the file. For in here I did the analysis. I differentiate between the 30 minutes duration and also video duration 50 minutes and 30 minutes. The resolution I test on 3 resolution, which is 640 times 480p, and then 720p and also 1080p video resolution. Same goes to the 30 minutes video duration. 40p, 720p and also 1080p. Each resolution I did it 3 times. So from here we can see that the compression size of the file before, we can see that on the 480p, before this the size is 67.6 megabyte, and now we can see that the size become 19.8 megabyte. So the size reduced is 47.8. Reduced percentage is around 70%, and also most of on the 720p we can see that most of the file reduced is 80%, which is, let's see, on here we see that 920 megabyte, but when it compressed it becomes 118.1 megabyte. So the difference, the compression reduce the size of the file that is reduced is really big, around 800. And also here we see the 1080p. 1080p is not the compression is not really that high, but the compression still comes with a great okay, like before this we see it is 1.8 gigabyte, and now after the compression it becomes 1.1 gigabyte. Okay, and also on the 30 video duration of 30 minutes, we can see that okay, before on in all of the compression file size, we can see that before is 10 megabyte, and then after that it becomes 50 megabyte. Also same goes to the other videos. All of them reduce really high. For example, like okay, this one from 2 gigabyte it becomes 280 megabyte. Okay, so we move on to the compression duration. Okay, in here we can see that the duration of the compression really it differs between on resolution. Okay, we can see that on 480p resolution the compression duration is really fast, but as the resolution becomes bigger, it takes a lot of time to compress the video file, even though the video duration is only 50 minutes. So, and also same goes to the 30 megabyte 30 minutes video duration, which the bigger the resolution, the longer the time taken for the compression duration to finish. So you can see here, and so we move on to the upload time. So okay, with the help of the video compression, it can reduce the time, the upload time of the files. Okay, let's see. On 480p before this, okay, the size of 67.6 megabyte. So the upload time before is 14 seconds. Okay, after the compression, 19.8 megabyte. The upload duration is only, the upload time is only 4 seconds, which the time reduced is 10%, and the percentage is 71.43%. Same goes to the 720p, which is before this it is 1.58 seconds. After the compression, the upload time is 70 seconds. So the margin, the size file that is reduced is really good, really really excellent. Okay, and then for this one, because the file is too large, because okay, the post the request post cannot handle file bigger than the because it can't handle file that is too big. And also because the Raspberry Pi I'm using is a Raspberry Pi with 8 gigabyte of RAM. But because of the while during the creation of this dashcam, my the Raspberry Pi OS is only 30. The available is only 32-bit 32-bit version of operating system, and the 64-bit is still on beta, which is not really stable, quite stable. So I use the 32-bit. So when I use 32-bit, the the RAM it will only utilize until 4 gigabyte, and so the other 4 gigs will not be used. So because of that, the memory allocation is, and the memory resource is not enough to handle file that is too big. So each time I want to do the test, it will display an error, say a memory error. Okay, so we move on to the 30 minutes. Okay, we see that okay here on 30 minutes on 480p, before this maybe okay, here we see 53 seconds. After the compression, it's only took 13 seconds. And also before this on the 720p, before is 2 minutes and 54 seconds. After the compression, it only takes around 45 seconds. Okay, so we move on to the project demo. Alright, this is my, okay, this is the camera. Okay, right now okay, in here, this is the is to import the module for this project. Okay, this project I use actually I combine 3 code inside this programming with this, which is the video capture. This is where it's which is it records the video, and then the espresso is for the compression of the video, and then for the upload is for the upload for the video. It will okay, here we can see after I combine all of this, okay, I combine it inside the Python name masterpiece. Okay, here the video will capture the with okay, for this test demo I will only use for ATP just to shorten the duration of the video. Okay, and also I'm got for for demo purpose I will only record for 2 minutes. Okay, once okay, here we can see, okay, the camera starts to, it will call the pi camera object, and then with this resolution it will record with this resolution. Okay, here is to where it retrieve the date and time to be used for the naming of the files. Okay, and then okay, it will record the video for 2 minutes, and then we will stop recording, and then okay, here I put a the loop only for two loop. It will loop 2 times. Okay, because for the demo purpose. Okay, and then else, okay, here also, okay, time sleep. Okay, here it will record the video and then put it inside the recorded video. Once it put inside the recorded video, okay, the while time sleep, okay, it will I think I'm gonna run this while explaining, so it won't take a lot of time. Okay, and then okay, so we see that it start recording. Okay, and then the file, it will wait for, okay. Okay, so here I use child, I use fork. Okay, so fork, if the, so it will run the system, the process simultaneously, the parent and the child. Okay, so here the parent, so if it is bigger, the process ID is bigger than 0, it means that it is the parent. It will run this if statement. Else means that if it is child, it will run this one, this command, this code. Okay, it will, okay, for here it will time sleep, which it will wait for the parent process to finish the first video. So right now we can see, okay, the video is 4.3 megabyte. So I'm gonna move the camera here. Okay, okay, here after that it will, okay, once the time sleep is already finished, okay, it will go to the recorded video, and then it will find a file with .264. okay, you can see that, and then it will start to compress the file. It will run this if statement, and then it will compress the file here, and then here it will, once the compression has finished, it will remove the file. Okay, once it removes the file, it will remove the file inside the recorded video, and then once it removes, it will run this one where the compressed folder, it will search for file which .mp4, because here we change the file name to .mp4, and then here it will find the folder with .mp4, and then it will upload the file to the cloud, to the Google Drive, and then once uploaded, it will remove the file. So we can see, okay, right now the size of the file before this is 11 megabyte. Okay, so we wait a few seconds for this to finish up. Okay, so this is what I'm sure is okay. This is the video folder for the video. Alright. Okay. Once it finish recording. Okay. Here, here inside this the name of the file. Okay, this it start now. It start to compress the video file. Okay, here we can see. Okay, this name is where it will upload the file according to the name here. So it will if the file here is not the same as this, it will rename the file inside here. Okay, so this is the parent where the ID for the parent. This is the ID for the parent. Okay, ID for the parent is for the video here. Put it here. And then, okay, this is the files where it will dump the files here. And then from the files, it will request and post the file. So, okay, once it finishes upload to the cloud, it will remove the file and then it will loop again, but we will loop here inside from here, here, because this is a for loop for until down here. So it will finish one by one. So once the video finish, okay, the video will still loop again, and then okay, now we here the file before this is not here. So okay, inside the compressed folder it also finished, because once it finishes here, the file here, it will start to upload. So here we can see the file has finished uploaded to cloud. So this is me. So while I'm recording here is the video. So okay, we can see before this the file, if you remember, the file size is 11 megabyte. Okay, now we can see the file size is only 3.1 megabyte. So the compression is around 8 megabyte. The compression size. And here is going for the second. Okay, so we can see that as long the camera will keep on recording the video, will keep on, and also the child process will keep on finding the files, and then it will compress, and then it will start to upload. Find file, record, find file, compress, and then upload it to the cloud. So the process will keep on going. Yeah. So we see, okay, so the file we can see the file here has already been uploaded to the cloud. Okay. And now proceed with this. Okay, project demo. Okay, so the conclusion. Okay. To summarize, all of the three objectives for this project are achieved, as the proposed dashcam prototype has successfully recorded the video and compressed it using the Ffmpeg video compression before uploading it to the cloud storage, and the result of the efficiency of the Ffmpeg video compression is really great, as the compression successfully reduced the file of the video, which saves a lot of storage space and also shorten the time taken for the upload to finish. Last but not least, with the three objectives are achieved, it indirectly solve all of the problem statement, which are storage limitation, corrupted files, and difficult to access with the usage of cloud storage. That's all from me. I'm Ffmpeg. Thank you for watching. Assalamualaikum.